Hello and welcome to this episode of Printed. In this episode of Printed, I'm going to be continuing the live sign construction. I got a little bitty LED bar in with a little bitty Pro Trinket. I'm just going to use that to power. I'm going to run the Pro Trinket off of a USB battery pack and just plug it in when I'm ready to do have the live sign be lit up. When looking for an LED strip of some sort that was small without having to waste a part of a strip or, well, not really waste, but I didn't need a full strip for any of the projects that I'm working on in the near future. So I just found a little bitty strip from Adafruit, and I saw that they actually had a on-air sign that they made that actually connects with the Twitch API. So I'm going to be looking into their project, which I'll link in the description below. And I might try to get mine to see if YouTube Gaming or YouTube's live streaming service has a API too, and try to get my little live sign to connect to a similar manner through Twitch and YouTube Gaming. If not, I have a little bitty Wi-Fi chip, and I plan on making kind of a network of little bitty devices like this, that LED lights and so on and so forth. So that'll be something I'm going to be doing in the future. I just wanted to get at least this far because it looks like I was going to be diving deeper and it's going to take possibly longer. And I just wanted to get this kind of project somewhat wrapped up for the time being. So without further ado, let's get started. So as you can see, the Pro Trinket has now been attached to the LED bar. Ground goes to the second pin on the Pro Trinket. 5-volt goes to the fourth pin on the Pro Trinket. And your data in goes to the your digital pin 6, which is the sixth pin. And that numbering is from the USB side. If you have the USB side facing towards you, it'll be on the left hand side. So I kind of skipped the actual step of me doing the soldering as it's fairly time consuming, as I was having a little bit of trouble getting the solder to attach to these little pads. And it's definitely not the cleanest job, but it should get the job done and at least get this project moving forward and completing our goal. We're now ready to do the software side of this project. It'll be very simple. We're just getting the LED lights to work right now. There won't be any networking stuff, and that will come later. But right now it's just the LED lights that I plan on doing. To add the Adafruit board, if you're using the same Pro Trinket that I am, you'll have to go to Preferences and click Additional Boards to manage your URLs. Enter that there. And now you'll be able to go to Tools and then Boards, and then go to the Board Manager. And now you'll want to at Adafruit AVR boards that it has the Pro Trinket. So we're going to install that. Alright. So now we have the Pro Trinket loaded. We should be able to choose it down here. There we go. The Pro Trinket 5-volt USB. And that is it. COM1 should be the Arduino. I already have it plugged in. So that gets everything ready for the Arduino Pro Trinket. It's not too hard. If you haven't installed the IDE, you can go to arduino.cc. I'll put the link to that in the description too, to get the Arduino CC IDE, which is great. If you've never bought an Arduino board, you can donate there too for the software. I've bought several boards over time, and we'll probably donate to the software side in the future too. But the boards themselves are kind of overpriced, but what they're doing with the software is building a great community, and for that, I think it is a great ideal to support them. And recently, at the World Maker Faire this year, which is just last week, or maybe even this week, all the news is kind of jumbled up, but it was announced that two different Arduino companies, which had split off a while ago over some differences, are now back together as one. So that's awesome. There won't be any legal issues holding back Arduino from going forward and providing a great system for prototyping, small projects like this, hobby projects, as well as education and stuff like that, getting programming to school. So it's a very good cause, so I definitely recommend supporting them. Alright, so now our Arduino IDE is ready for the Pro Trinket board, but we still have to add the library for the NeoPixels. So for that, we're going to go to Include Libraries, Manage Libraries, and we're going to use the search tool to type NeoPixel. And we are going to install that. A long time ago, they didn't have all these tools, or at least they were more obscure. It wasn't as easy to load libraries. You had to do a lot of it manually, or it could just be remembering things wrong. But they may have made it very easy to add libraries and add boards and stuff. And Adafruit does a good job about updating all their stuff and getting everything to the Arduino IDE, which is good. And kind of like Arduino, Adafruit stuff is pretty costly, definitely compared to like some of the Chinese versions you can get from the internet, but they're always good quality. I've never had any issues with any of the boards or components I've gotten from them, and they have a lot of support, so I like supporting them in that regard too. So now that you have the library loaded, we can go to Sketch, or sorry, File, Examples, and we're going to load the strand test from Adafruit NeoPixel. And here we're just going to double check and make sure our Pro Trinket and the COM1 are checked. Then I'm going to try uploading. Alright, upon trying to upload, I had an issue, and then I realized I skipped a step. You need to set the programmer to the USB Tiny ISP, and we'll see if that works now. Okay, so that is now working. My NeoPixel has changed from, or my Pro Trinket has changed from a red light that was pulsing to a solid green light only. So as you can see, the file has now uploaded fine. After changing that to the programmer to USB Tiny ISP. And make sure that if you have the red, green, white version, that it says red, green, blue, white is going to be your thing. When first programming, the Pro Trinket had a red pulsing light as well as the solid green light, and now you can see the red pulsing light has turned off. And now the NeoPixel is just running through a random test to just show off all the colors and stuff. So right now it's kind of like a pink going to the purple, turning to a blue color, just running through just a generic test just to make sure all the pixels are working. And and you have good color. So as you can see, it has a pretty good wide range of colors. I don't know how good that's coming through on the webcam, but it goes from a green to a red and the blue pixels, your green, red, blue, and the mix between them, you can get pretty good shades of pink, purple, and so on and so forth. So we are now ready to actually start modifying this base code to do something that will fit kind of what we're more looking for. All right, so I've decided what I want. I'm going to make a utilize the chase, which will kind of go through the well, it won't go through the colors because I'm going to have a solid color. I'm going to have orange, but it'll kind of give it a flicker effect, and it could look pretty cool. So I'm going to go ahead and try that real quick. So I'm just going to delete all the code that I don't need. If I ever need to go back to this for some reason, I can go back and open the example again. So don't worry about messing up something with an example. The example code, as far as I know, can't be ever written. But I guess it is possible. Never actually tested that. And I decided I wanted an orange color. So I'm going to go with 255, 128, 0. And I have the white strand, so I could put another number there for white. But I'm going to, sorry, I'm going to just leave it out and to see what it looks like without that. So that should just run just the theater chase, and we can go down here, and you can look at their function that they've already used. Now you can just use the code that they've already written, or you can write your own code for what this thing is doing. I don't need nothing fancy, but for other things, writing your own code could be very cool. You could do certain delays and to make very cool effects with your lighting, depending on what you're actually trying to do. So it's going to just do 10 cycles of chasing, and it'll go through those really fast, as you kind of saw in the video. So that should work pretty great. And it's pretty much ready. I'm going to go ahead and save this as to my desktop for now, and live sign. And I will put this code on the web, although I've not really changed anything. I will just upload it if you just want to copy directly what I'm doing. So I am now ready to upload it again. Now on the NeoPixel, I will go ahead and adjust this camera angle again. On the NeoPixel, you will need to push the button to get that pulsing red light again. That lets you tells it that it's in program mode, and go ahead and upload. Alright, so I'm getting some very weird colors. I think that's because I left the white out. It might actually be required for what I'm doing. So I'm going to go ahead and add a 0 in there for the last white and just see what that does. Then I'm going to go ahead and hit that button right there at the far end, hit the red pulsing light again, and upload again. Alright, still getting this very weird rainbow. It could be that I'm using the wrong function. I thought that was the one that just was a solid color, but I will look through that code real quick and see what that was. Alright, so as you can see in the video, if it's not ever washed out from the brightness, I have a nice orange color, a nice bright orange, kind of yellowish, but definitely orange color. I figured out after a lot of trial and error that even though I have the white pixels, and maybe I got the wrong ones in, but they do have the little half yellow, so they should follow the NeoPixel red, green, blue, white order. But I just tried out on a whim to do the green, red, blue, because I knew red should be the most, followed by green, then blue. I tried that, and it actually finally got an orange, which makes sense because red and green are flipped. So when I was doing it in the order I thought it was supposed to be red, green, blue instead of green, red, blue, I was getting a very green. And I thought maybe at first that it just favored green heavily, but it doesn't seem that it's that way, and it just was in the opposite order than I thought for the first two variables. So I will go ahead and upload this. I didn't really change much. I just have a single thing going. I left all the functions there so I could go back and look at them in the future if I wanted to do something a little bit more in depth. But for now, I'm just going to keep this and see how it looks. So I'm just going to go ahead and get my battery pack. I have it charging. I'm going to test out if this works with the battery pack and kind of get an idea of how long that'll last, and if that would be a good solution. Actually, after having set this up and looking at it, it actually might be, with this light here, it actually has a nice little flicker effect, like a flame. And I'm thinking about using these possibly for pumpkins in a couple weeks, getting several of these additional boards. They're only like $5 a piece for the LED strips, and I could always reuse the trinkets in the future. So it's should be a fairly cheap project, and should be a nice way without having to deal with candles to have LED lights. If the battery packs work, I could run it off battery pack overnight, charge a USB battery pack during the day, and have essentially a never-ending light as long as when it's dark outside. So I will go ahead and grab my battery pack, and it'll be right back with that. Alright, so I now have the LEDs and the Pro Trinket attached to USBs. It works just fine off a USB drive. It doesn't seem to be pulling too much juice. The board, I've just kind of touched the chipset on it. It's not getting hot. Doesn't seem like any of the components are really getting hot. You wanted to be somewhat careful. I didn't want to short anything out, but nothing seems to be getting warm at all after letting it run for quite a while. And I'm pretty confident with that the battery will work as long as the battery pack actually contains charge. So I don't think there's anything wrong with actually using the battery pack from my experience. I did have problems with the battery pack that I have. It's a 10,000 milliamp Amazon Basics battery pack. I've had it for several years. The capacity's gone down a little bit just from all the charge cycles. Pretty much use it almost on a daily basis. But it's a great battery pack, but it's just a little too big. However, you can kind of see the ideal in general working. I will turn off the lights. I have a lot of lights on for the camera, but I'll turn the light off to give you a little bit better idea of what it's going to look like. But I will have to get a smaller battery pack, but I would like to test this battery pack to see exactly how long it's going to last, just to get a rough estimate of, you know, for 1,000 milliamp hours, you can expect 1 hour, for instance. Alright, so you can kind of see, it looks pretty cool. The flickering thing, you can see a little bit. It's not insane flicker, but with it being obstructed, it kind of cuts the flicker out a little bit. But for like the pumpkin thing, when you're having the light being shown through the open parts of the pumpkin, I think it would work perfect and look really awesome, to be honest. Whenever I finish this and get a USB battery pack that can actually fit inside here, I'll probably go ahead. There's some mounting holes in these boards. Mount them to the back panel, and then have the USB set inside of this bigger box, and just try to find one. I think Amazon even has a basics version that's half of this size, and it might fit inside of here, or I might just get one of those little lipstick ones and see approximately how long they last. Thanks for watching, guys. If you found this video informative or enjoyable, make sure you give it a big like. That helps the channel in general, and I greatly appreciate your feedback. In addition, make sure you subscribe to my channel to stay tuned for more great projects in the future, possibly the continuation of this thing. I don't really have a timetable for that, but as well as other cool projects that I'll be working on in the future. Thanks for watching, and make sure you check the links in the description below if you want to do this project yourself. I will have links to different products, the 3D printing files, as well as other links to the different communities and places where you can follow me, such as Twitter and MZ. So thanks for watching.